All right, guys. So this is a test review, and so question one, you're asked to solve each of the following by factoring and the zero product property. Well, it's already factored. So you have two factors, 4x minus 2 and 2x plus 8. So the first thing you want to do is you want to set each factor to 0. So this is my first factor. So I'm going to get 4x minus 2. I'm going to set it equal to 0. My second factor is 2x plus 8, and that is equal to 0. Now, once there now, I need to find the value of x. What is x equal to? Well, on the first equation, right, I have a negative 2 right here, so I want to eliminate that. So I'm going to add a 2 to the left side, but what I do to one side of the equation, I must do to the other side. So I'm going to add a 2 right there. So that's going to give me now 4x is equal to 2. All right. So when I add, that cancels out. So I'm left with 4x equals 2. Now to get x by itself, I have to divide each side by 4. So I'm going to divide by 4 here, divide by 4, and that gives me x is equal to 1/2. Okay, so that's one solution. And on the other equation, I have 2x plus 8 equals 0. All right, to get the 8 to the other side of the equation, I'm going to add a negative 8 to both sides. And when I add, that's going to give me I'm sorry, wrong color. That's going to give me 2x is equal to negative 8, all right? Because when I add, that goes away, and I'm left with negative 8 on the right side. Now, to get x by itself, all I'm going to do now is divide by 2 on both sides. Divide by 2, and that gives me x is equal to negative 4. X equals negative 4. All right. So that's number one. And number two, do I have any more space? Okay, let me extend my page a bit. Number two, 3x minus 7 and 4x minus 6. Um, 3x minus 6, I'm sorry, 3x minus 7. So 3x minus 7 and 4x minus 6. Let me verify if that's other two factors. Yes. And that is equal to 0. Okay, let me make this x a little bit more pretty. There you go. Again, I want to solve for x. So I'm going to set each factor to 0, all right? My first factor is 3x minus 7, and that is equal to 0. And my second factor is 4x minus 6, and that is equal to 0. So the first step now is I need to get the 7 on the right side of the equation. Therefore, I'm going to add 7 to both sides. And when I do that, I'm left with 3x is equal to 7. Okay, because these two cancel out. Extend my page a bit. Now I have 3x now equals 7. To get x by itself, I'm just going to divide by 3 on both sides. And I'm left with x is equal to 7 over 3. The 3 cancels out. On the right side, same process. I'm just going to add a plus 6. Oops. I'm just going to add a plus 6 here. And remember, what I do to one side of the equation, I also have to do to the other side. Plus 6. And when I add, I'm left with 4x is equal to 6. And then I'm going to divide both sides by 4 to get x by itself. Divide this by 4, this by 4. I'm left, that goes away. So I'm left with x is equal to 6 divided by 4. And you can reduce that to 3 over 2. Okay? So those are the solutions to the polynomial. All right. Okay, let's go to that's 1, 2. Next page. Okay, state the vertex and the axis of symmetry of the graph of the quadratic function. Okay, so the vertex. So remember now, this is h and that is k. And when we write the vertex from the function, right, you're going to change the sign of h. So right now it's a +2, but when I pull it out, it becomes a -2. Make sure you flip that sign. The 3 stays the same. So that's my vertex right there. And the axis of symmetry is always, it has the same value as the x coordinate of the vertex. So that's going to give me x equals -2 as the axis of symmetry. All right. Number 4, again, this is my h, and that's my k. Now remember, for the h, I'm going to flip the sign. So that becomes 1, -4 for the vertex. And again, the axis of symmetry has the same value as the x coordinate. So that's going to be x is equal to 1. All right. Okay, let's move on to the next one. Here, you're given a graph and you're asked for a lot of things. So let's start off. Okay, let's see. Vertex. Remember, vertex is the lowest, is a point in the graph where the graph changes direction. In this case, the graph is going this way and it changes. So this point right here is the vertex. As you can see, it already has a dot there. So what is that point on the graph? Well, that point is -1. And how much is this? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 units down. So the vertex is -1, 9. Is that a maximum minimum? Well, that's minimum because it is the lowest point in the graph. So this is a minimum. And the axis of symmetry, again, it's a line that splits the graph in 2 equal halves. And so we can do it graphically. I can draw a line, and you see it crosses the x-axis at -1. All right, splits the graph. Well, not a pretty line, but you get a picture. There you go. All right, and so it's x equals -1. And if you notice too, it is the same, again, it's the same value as the x coordinate of the vertex, all right, -1. X-intercepts, what are my x-intercepts? Well, on the right side, I have 2, so it's at 2, and on the, let's go with blue, and on the left side, it is 1, 2, 3, 4, 2 and -4, okay, on my x-intercept. And you can write them in order pairs too. 2, 0 and -4, 0. All right. All right. Y-intercept. Okay, that's where the graph crosses the y-axis. That's this point right here, and so that is 0, -8. 0, -8 is my y-intercept. What's my domain now? Well, the domain is going to be all real numbers because the graph has no end. It keeps on going all the way up, right? All the way up. And so the x values decrease that way to -infinity, and the x values increase this way to +infinity. So my domain, we can say all real numbers, which we use a fun looking R. All real numbers are, we can say, from -infinity to +infinity. I'll put the x in the middle, and then remember we use a less than symbol with it. Okay, range. How do we get the range? Well, let me erase this for a second. Okay, range. Now remember, range are the y values, or the height of the graph. So if I, let's see, okay, if I have this ruler right here, right? Is it going to work? Okay, if I have a ruler right here, right? So I'm going to go up. I'm going to approach the graph from the bottom, and wherever the graph touches the graph, wherever the ruler touches the graph, right? That's the beginning of the domain, and that is what -9, right? So that's the lowest point of the domain of the range, -9. Okay, -9. Okay. Now let's keep on going. I want to see, am I going to get to the top of the graph? Well, I'm going to keep on going, but I'm not, right? Because the graph has arrows, and that tells you that I will never get to the top. So that's going to be +infinity. So let's do it a little bit that way. So there's two ways you can write this. Uh, um, that's my y for domain for the range, and I use less than or equal to y and less than positive infinity. Or I can say the domain, because there are no y values down here. The range are all the y values that are greater than -9. So I can write y is greater than or equal to -9. All the y values that are above -9. All right, is the range. All right, so that's number 5. Let's see what's next. Okay, give circular function that has zeros of 3 and -4. Okay, so let's look at 1. All right, we have x plus 3 and times x minus 4, two factors. Are the zeros 3 and -4? Let's see. If I make this equal to 0, x plus 3 times x plus 4, and I set that equal to 0, what am I going to get? Well, I'm going to get x plus 3 is equal to 0, right? And can I squeeze in x plus 4 here? X plus 4 is equal to 0. Now, to solve for x, I'm going to add -3 on both sides. And by now, you guys should know this, -3 on both sides. And that's going to give me x is equal to -3. On the other equation, if I add a -4 on both sides, that gives me x equals -4. That gives me -4. So 1, so this is not an option, right? So 1 is not an option because I have a -4 here. Oh, this is a +4. I'm sorry. This should be a -4 here. Oops, -4. And yes, I'm going to have a +4 here. And yes, so this gives me a x equals 4. All right. So yes, correction, this is correct. So that's part of my answer. What about 2? Okay, so we got to factor x squared minus 2x minus 8. And you could do this 2 ways. You can put that into the calculator, right? Plot the graph into the calculator and see where the graph crosses the x-axis, or you can use the Xbox method, right? So I don't have my calculator with me right now, so I'm going to do a quick Xbox method to see if that works. 1, 2. Where's number 3? I have 1, 2. Okay, we're missing. Oh, the graph is 3. Okay, oops. Okay, so let's solve for x squared. I'm gonna use the Xbox method for that one. Okay, since I don't have my calculator with me to punch it in. So the first term gets x squared. The last term gets -8. And so I need to find these two corner boxes. So my top number is going to be -8, right? And my bottom number is going to be -2. So what two numbers, when I add them, gives me -2, but when I multiply them, gives me -8. And that is going to be -4 and 2. So this becomes -4x, and this becomes, and this becomes 2x. So my factors are going to be an x goes there, an x goes there. This is a 2, and this is a -4. And so, well, I know that's not, because my factor is going to be now x plus 2 and x minus 4. Well, that's not going to be 3 and -4, right? Because I have a 2 here. So that's not going to work. So 2 is not going to be the answer. Okay, let's look at the graph and see what are the x-intercepts for the graph. Well, here it's going to be 1, 2, 3, 4. So that is a 4. The x-intercept is 4. And on the left side, 1, 2, 3. The x-intercept is -3. So yes. So this one is number 3, right? Yes, this is number 3. So number 3 is good. And number 4. So remember now, for the x-intercept, right, y is always 0. So let's see. Y is 0, then this is x-intercept 7. That's not what I'm looking for. Y is 0, x-intercept is 8. That's not what I'm looking for. So the only two answers are 1 and 1 and 3. 1 and 3. 1 and 3 are the answers. 1 and 3. Okay. All right, that's number 6. Let's look at number 7. Okay, you're given a function that describes the trajectory of a soccer ball. It's given by the function f of x is equal to x minus 3 squared plus 35.5. And x showed time in seconds when the ball was kicked. Okay, so question A is, what is the approximate height of the ball when it is at its highest point? Okay, so the highest point is right here. And so that is, if I come across, that is 37.5, right? So the height is 37.5, and what's the units? Meters. Okay. B, how about how long was the ball in the air? Well, the ball was kicked from this point right here, and as it travels in the air, time goes increases, and it comes back down to 5.5. So the total flight time of the ball is 5.5 seconds. Okay, and C, approximately when was the ball 30 meters in the air? Well, let's see. The ball was 30 meters. The ball was right here, and that's on its way up. And on its way down, the ball was right here, also at 30 meters. So there are two different times when the ball was at 30 meters. The first time is 1.5 seconds. Let me erase this so I can see clearly. Yes. So t equals t equals 1.5 seconds. And the other one was when t is equal to 4 seconds. T equals 4 seconds. Those are the two times. All right. Okay, let's move on to the next one. State the zeros, then write an equation for the quadratic function in factored form. So we got to state the zeros, then write the equation in factored form. All right. So remember, factored form is, that's what we're looking for. Okay. So the zeros are -4, -4, and 2. Those are my zeros, all right? So to put them in factored form, that's going to give me, I'm going to change this now to, this is going to be x plus 4. And for the 2, it's going to be x minus 2. So all you do is just change the signs. So, all right? So those are, that's the equation in factored form. And the zeros are -4 and 2. Okay, next one is number 9. Okay, what is number 9 saying? Zeros and equation. Okay, same thing, zeros. For number 9, the zeros are, remember, zeros are where the graph crosses the x-axis. I want to clarify that. All right, so zeros are, on the right, we have 1, 2, 3, 4. So that's 4. And on the left side, we have 1, 2, -2, right? Therefore, when I put it in factored form now, I'm going to change the signs. So that's going to give me x minus 4 and x plus 2. Okay? Okay, let's see what's next. All right. Describe how the graph of f of x equals x squared would differ from the given function. Okay, so the new function is x squared plus 16. Describe the translation. Well, this is my k value, right? 16 is my k. And so it tells you whether the graph goes up or down. In this case, right, the graph travels 16 units up from the original function. So the graph translates, right, up 16 units. I said 16 units, or the graph went up 16 units, or went, I say goes up, goes up 16 units. All right. Next one, same thing. It is negative, K is negative 49, therefore it went down. So goes down, goes down 49 units. 49 units from the original function, parent function. Goes down 49 units. Okay. Describe the x-intercept for number 12. There's the graph does not cross the x-axis, right? So there are no x-intercept. No x-intercepts. All right, no intercepts. Okay, and you can put it punch this into your calculator, and it will look like something like this. All right. So let's where this is 16 right here. So the graph never crosses the x-axis. There's no solution. All right, and on this one, okay, let's do 13. Describe the x-intercepts. The graph crosses the x-axis, and so I'm going to have a positive 7 and a negative 7 x-intercepts. And you can solve this by taking, let's do this real quick. Okay. Let's write this as x squared. Oops, I need my x squared minus 49. So you can, there's two ways. You can use a calculator, plot the graph, and you can see where the graph crosses the x-axis, right? That's one way. Or you can do it algebraically by taking the square root of x squared and the square root of 49. This is x, and this is 7. And so that's going to give you x minus 7 and x plus 7. All right. And so you can get x equals 7 and x equals negative 7 as your x-intercept. So that's one way of doing it. Or you can punch it into the graph and look at where it crosses the x-axis. Okay. Next one, factor the quadratic equation above. Again, because there are no x-intercept, then you cannot factor it. So cannot factor. Cannot factor. And I think I just did this. I just factored it here in this answer. Okay. Okay, so the factors are x minus 7 and x plus 7. Okay. All right, so that's it for that one. Okay. What's next? Okay, look at the function, then state the transformation, vertex, and axis of symmetry. Ooh, it's a lot. All right, so here we go. First thing, let's state the transformation. Well, okay, this is the vertex right here of the graph. So it went, it got shifted how many units over? Well, 1, 2, right? So it shifted left. Okay, let me write this right here. Transformation shift left. 2 units, right? 2 units. And then it went down 1, 2, 3, 4, and down 4 units. Okay. So shift left 2 units and down 4 units. And what is the vertex? The vertex is going to be -2, comma, -4. -2, comma, -4 is the vertex. And the axis of symmetry, just by looking at this x value right here, we know it's going to be x equals -2. Or you can just draw a line that splits the graph in two equal halves that cross the vertex, and it crosses the x-axis at -2. All right, so that's x equals -2 right there. What else? Domain, again, the graph is continuous. It never stops. All right, so my domain, the x values keeps on decreasing to -infinity and keeps on increasing to positive infinity. So the domain is going to be all real numbers. So we can use all real numbers as with the fun looking R, or we can write it as -infinity to positive infinity, put an X in the middle and the less than symbol. So those are two ways you can write it, okay? And let me put a slash to say a different color. Two ways you can write it. And the range, again, remember my ruler trick? All right, if you have a ruler and you start from the bottom of the graph, all right, insert. Can I do that over here again? Measurement tool, ruler. Okay, where did it go? Oh, here we go. All right, so if I bring my ruler down, oops, not so fast. Okay, all right, I'm gonna bring my ruler up now, and the first point I'm going to hit that graph is at what? 1, 2, 3, -4. So -4 is the lowest point on my range. And I'm going to try to get to the top of the graph. But you know I'm not going to get to the top because the graph keeps on going all the way up, right? So that's going to be positive infinity. So I can write my domain in two ways. I can say it's going to be all the y values, right, that are greater than -4. All the y values, right? So that's one way of writing it. And that's going to be y is greater than or equal to -4. That's all the y values that are greater than -4. And or I can say -4 is on the left side of my domain, positive infinity is on my right side. And then I keep on saying domain, my range. And then I'm going to use less than or equal with -4 and less than with infinity. All right. So another way, two ways you can write the range. Okay. Let's see what's next. Same procedure. Okay. So we got to find transformation. What is transformation? Well, let's see. This is the origin right here. That's the origin. So what happened to this graph now? Well, it went over 1 unit, right? So it shifted to the right 1, and it went up 1, 2, 3, 4, 5, 6, 7, 8. So transformation is shift right 1 unit, and up. Did I say? I forgot. 9, yeah. No, 8. 5, 6, 7, 8. Up 8 units. Up 8 units. Okay, so that's transformation. The vertex is just going to be 1, 8. 1, 8 is the vertex. And you can see that the vertex is right here. So that's going to be 1, 8. And the axis of symmetry, you know it's going to be the same value as the x coordinate of the vertex. That's x equals 1. And my domain, again, is going to be, you can tell, right? All real numbers. Because the x values for this graph just keeps on going to -infinity. And on the right, it just keeps on going to positive infinity. So my domain is all real numbers. We can use a fun looking R. And then R, it can be negative, oops, it can be -infinity to positive infinity. Domain, and we use a less than symbol. Okay. On the range, again, if you use that ruler trick, all right, insert, let me insert this ruler. Where is it again? Measuring tool, ruler, and it's right here. Let me see if I can bring it down. Oops. Okay. My ship is sinking right there. Okay. All right. I'm not sure what I did on my ruler right here, but you kind of get the picture, right? So I'm going to slide up now. I'm going to slide up. Let's see. Where do I hit the graph first? All right. And I hit it at 8. All right. So my range starts at 8. So I can say the range is going to be all the y values that are greater than or equal to 8. That's one way of writing it. Or I can say from -8, I'm sorry, not -8, from 8 to positive infinity. And because I'm talking about range, I put a y in the middle. I put less than or equal next to the y on the left side and less than next to positive infinity. All right, so that's one way of doing it. And let me put a slash right there. All right. What else we're looking at? Range, that's it. All right. Next question is, okay, transformation. Okay, transformation. Let's see. The graph, this is the origin. So it went over 1, 2, 3, 4, 5, 6 units. Shift 6 units to the left and up 1, right? Up 1. So shift left, um, 6 units, shift left 6 units, and up 1 unit. Okay, and vertex, the vertex is going to be -6, 1, -6, comma 1. And also, I just realized you can also look at the equation, right? So this is my h, this is my k. I'm going to flip the sign for the h. So that's become -6. The 1 stays the same, 1. So that's how you can get the vertex too. All right. Okay. Axis of symmetry is going to be x equals -6. All right. Same as the x value right here. Or you can just draw a line through the graph. All right. Draw a line. It's going to split the vertex at -6. All right, so x equals -6. Okay, domain, again, look at the graph. It's going to be all real numbers, right? All real numbers that fun looking are from -infinity to positive infinity, x less than. So one option. And the range, I'm not going to use my ruler trick anymore, but if I go up, you see I'm going to hit the graph at wait a second. Yeah, I'm going to get the graph at 1, right? So 1 on the y-axis, I'm going to hit the graph. So there are no y values down here. There are no y values down here. So it's going to be all the y values that are greater than 1. So I can just write y is greater than or equal to 1. Let me keep on using red. Y is greater than or equal to 1 as my range. And also, you can notice, right, this graph has no solution, no resolution, right, because it does not cross the x-axis. All right, no resolution. All right, let's see what's next. Okay, and the last, number 17, what is the solution set of the equation? Well, all we're going to do is just set both factors to 0, right? Don't let the C throw you off. Just set each factor 0, x minus 6 equal to 0, and x minus c equal to 0. And just solve. I'm going to add a +6 here and a +6 there. So that's going to give me x is equal to 6. And on the right side, I'm just going to add a c, a +c here, and a +c on both sides. And when I add, that gives me x is equal to c. So that's my solution set. All right, guys, I think that's the end of the review. Yep, end of review. All right.